As a public university, UVA is ranked number 2 in the country, and more than 50% of the undergraduates take physics courses. And we offer students an education experience that emphasizes critical thinking and also active learning.
One of our great strengths at the university is a very strong student body, and they are smart kids, they get engaged in the classes, and we've reached out to them here as a physics department. So for example, my How Things Work class, which is physics in the context of everyday objects, has drawn in about 10,000 students since I started doing this. And at times, I've reached approximately 50% of the possible audience at the university. How Things Work isn't a missionary class where I'm trying to get them to come to me. I'm trying to go to them and teach them physics that's valuable in their lives so that they can go about the rest of their time here and elsewhere understanding the world around them. It's sort of a user manual to the real world. And part of the value of a public education is an informed citizenry. So that's one of our goals really, is to get people to understand their world, act in an informed manner for the rest of their lives.
Our faculty are involved in a variety of exciting research areas. That includes nuclear and particle physics, atomic and optical physics, condensed matter physics, material physics, and nanotechnology.
Well, the discovery of the Higgs boson, or a profound discovery like this, comes along once every 50 or 100 years. The role of myself and the team at the University of Virginia and the Higgs boson decay was to, first of all, be a member of the Analysis Review Committee that was responsible for releasing the Higgs discovery to the public in the middle of last summer. The second part was our work on the electromagnetic detector, which is made up of 74,468 lead tungstate crystals in which the decay to 2 photons are detected. The students had an absolutely unique experience. This doesn't come along very often in physics, where you have such an opportunity to be on the ground floor of a profound discovery.
I'm a condensed matter experimentalist. This is a very broad field and encompasses many different areas of research. I would say this is a field where discoveries in the lab can easily translate to new technologies. So one of the things that we are working on are superconducting materials. We are very excited about that because this particular system shows superconductivity, which is where you can imagine electricity being transported with zero loss for long distances. That would be an amazing thing if we managed to do this for everyday life.
My research is in the experimental subatomic physics, which encompasses nuclear and elementary particle physics. My studies focus on the nucleon and the mesons that are way stations along that way, along the road to ever smaller particles. I typically have 3 to 4 graduate students in my group and a similar number, 3 to 4 undergraduate students at any time.
So graduate students are absolutely crucial. They're essential. They are the life and blood of the research effort at the university.
Students are very important in my lab because they're involved in all different facets of the work. And a lot of times students have this, unique perspective because they come in the field brand new. And they can sometimes ask questions that you haven't thought of. So this often leads to new results that are always very welcoming because it's something you haven't thought of.
I love teaching. I teach first years, advanced grad students that do the whole spectrum, and it's fun because it's part of my job to teach.
The physics department is small, but we do have a diverse group of people. We do have diverse capabilities. We do collaborate amongst each other. We are very close to national facilities that we make use of. I think for the research purpose, that's fantastic. Our students are very engaged in research. This is very important for a research university. Both undergraduates and graduate students are fully engaged. This is our future. I think as an investment to the future, we have to focus on them. I feel very fortunate to be here.